All right, so actually I decided to start a new lecture and to talk about pointers versus references a little bit more due to some questions that came in. So let's get rid of this stuff down here at the bottom. Don't need it. All right, and so we've talked about pointers, and pointers are a way to change data inside a function. So references, why use one over the other? Okay, let's write two functions. Void f1 does it by pointer, right? So it's going to take a reference to a, it's going to take a pointer to an integer, and it's going to set that pointer equal to 10, right? So star I equals 10. Now, whenever I have a pointer variable, I like to put a P in front of it just to indicate that it's a pointer. All right. And so if we call it, right, if we create a variable, x is equal to 10, and then we call f1 and we pass in the address of x, right, so that we're passing it in as a pointer. Then if we see out, oh, let's change it to something other than 10 because, you know, it's 10 there. So then we see out x, right? It should say 10 because we changed it by its pointer there. So using namespace std, let's also get string in there. All right. Okay, and so it is 10, right? And we could do the same thing with references just as well. Make one called f2 that changes it by reference. So change a value by pointer. Void f2 takes a reference, so we're going to define it with an ampersand. I like the language C# where you actually use the word ref there. I think that's a little bit clearer. But anyways, so we're going to pass this in, pass in I as a reference, so we just change I is equal to 10. Now the syntax for that is clearer, isn't it? A bit cleaner. That would be one reason to prefer references rather than pointers, but I'll show you a much more important reason. Okay, so let's pass in I, right, into F2. Excuse me, let's pass in X into F2, and it's going to get set to 20. So the next time we print it out, it'll be 20. Okay, so it printed out 10 and 20. So far, so good. We don't have a reason to prefer one over the other, do we? Well, we do. Let's keep going with our examples, though. Let's create a variable called px that's a pointer to x, right? So px has the address of x in it. Got to put that ampersand there, right? Pointer px has the address of x, right? And we can pass that into that function, right? We don't even have to put an ampersand in front of it because it already is a pointer. And if we print it out, it's going to be 10 again. All right, so that's all well and good. But what if something happens to px? Like what if we increase px by 1, right? Like that. Now it's not pointing to the right place anymore, right? It's pointing to the wrong bytes in memory. It's like I told you that my mailbox number is 32, and then you start going and looking in mailbox number 33, because of the plus plus. But we're passing in that 33 into this function, and we're going to try to change mailbox 33 rather than the correct one, which is 32. And we don't even have a mailbox 33 in this program. So that's an erroneous statement, but it's going to have bad consequences. It could conceivably crash. At the very least, it's going to overwrite some memory that we don't want it to overwrite, and we won't know that it happened. It won't crash. It just may cause the program to malfunction in the future. Or it is going to crash, which is actually the preferable thing, right? You don't want your program to keep running with corrupted data. So now when it runs, it should throw an exception and crash. And it did, right? Runtime check failure. The stack around the variable X was corrupted. Okay, so we see the danger. It's easy to crash your program by using pointers incorrectly. That's the big reason to use references. There's really no way I can break this and cause this statement to crash, right? It doesn't matter what I pass in. The compiler makes sure that it's an integer that it has write access to. So using references is far safer than using pointers. So changing px before we pass it to the F1 function can cause the program to halt with an exception. This happens easily with pointers. Now, in this simple case, it looks obvious why it broke, right? We can see that we changed px and it's real obvious. But what if something had happened like we forgot to initialize it, right? We declared the variable. We forgot to initialize it, right? And then it's going to run. It should also crash because we're using an uninitialized variable, but that function doesn't know that it's uninitialized, right? F1 doesn't know whether it's initialized or not. Maybe it does. Let's go and take a look. It'd be nice if it did. Hopefully I'm mistaken about that. Uninitialized local variable px used, okay? But what if I had set it equal to 0? Or what if it had been set to a structure, but then that structure had been deleted, and so it now pointed to invalid memory? That's the kind of thing that can happen. And again, it blew up. Write access violation, right? Because we tried to write to the address 0, which is impossible to write to, right? That's the beginning of memory. It's certainly not any memory that this thing should be able to access. So hopefully, since I've shown you 2 different ways that that function that changes it by pointer could crash, where was that? That was here. Then you'll decide that, yeah, if I can use references, I will. All right, a little bit more about pointers. You can have pointers to pointers, which sounds absolutely absurd, doesn't it? We've already seen that you could create some kind of structure. I'm just going to create a structure called data. And all it's going to have is an int x and an int y in it, right? So Victor, you're going to want to come back and watch the first 11 minutes of the lecture because I was talking about pointers. So we have a structure here that's got 2 variables in it. And I'm going to create a pointer to a structure so that I can allocate it, right? Data star PD is equal to new data, right? And I can set PD arrow greater than X equal to 1, right? And PD arrow greater than Y equal to 2, like that, right? And then I could do something with it. But let's say that I wanted to stick this code inside a function. So struct, okay, excuse me. And normally when you do this kind of thing, you're going to make it so that you return the value rather than pass in a pointer and have it work. But we're going to try to get it to pass in a pointer and have it to work, right? So void make data, right? And it's going to accept a pointer to the structure. So we need a data pointer. And let's do the same thing, right? PD is equal to new data. We create a brand new one, and we set X and Y equal to 1 and 2 respectively. We don't need to be creating it here, right? Because we're going to change it inside this function, right? So make underscore data, passing our pointer into it so it can change it. And we've already got an R. Since I called that uppercase D and lowercase d down here, had a disagreement. And then let's see out PD greater than X followed by a space followed by PD minus greater than Y followed by ENDL, just so that we'll see this as 1 or 2. Spoiler alert, it's probably not going to. Build errors. Well, okay. Did it catch the problem for me? Or is it a different error that I'm not expecting it to have shown? Let's view the error list. Uninitialized local variable PD used. True enough, right? We're passing in this thing into a function. Well, what are we supposed to initialize it to? I don't know. We're not going to make a new object because we already make a new object here, right? Very first thing inside that function. So why would we want to make a new object here? So let's just set it equal to null. Null just means it doesn't contain any data yet, but at least it's not uninitialized. So the compiler is going to go ahead and compile it and run it, hopefully. And it does blow up. It says exception thrown. The reason why is just like before, when we were trying to write a function in, void F3, and we passed in something not by pointer and not by reference. And if we did that after we were done with that call, X would still be its original value down here. It would not have changed. The same thing is true here. PD still has its original value. Even though we changed what PD is here, it's got its original value here. So what you got to do is you got to declare a pointer to a pointer. And it sounds crazy, but anytime you want to change the value of that variable, it has to be a pointer, right? The better thing to do, maybe you would make it to be a reference, I don't know, but we're going to pass it in as a pointer to a pointer. Now, since it's got 2 stars here, I'm going to put 2 P's there. And to dereference it, I have to put an asterisk in front of it each time. And it didn't like that. Well, I know how to fix it. You know what I'm going to do? Because I'm going to go back to the way it was, and I'm going to make this a pointer to a PD so that I can do all that stuff. But then I'm going to say asterisk PPD is equal to PD, right? Change this pointer's pointer equal to the address that's contained in PD. And that's kind of subtle, and I'm sorry it is. But you can pass in pointers to pointers if you need to change the value of the pointer that's coming in. Now it should work just fine. All right, so it's going to run. Or not. Aha. See, I need to pass it in as a pointer, so I'm going to put an asterisk there. Excuse me, an ampersand there. And so PPD is a pointer to a pointer so that we can actually modify the value of the PPD pointer and not just modify what it points to. All right. Yeah. So if I was going to do this a different way, try to make it better, what I probably would do is to make a version of make data that just accepts a reference, right? It's going to look kind of weird if we pass it in as a pointer reference, and I'm not even sure how to do that. Void make data to, and it's going to take, you know, what is it? And reference to a pointer. Where pointer to a reference is not allowed. How about reversing the order? Yeah, that works. Looks weird, but it works, right? And then we could just do this part and it would work cleanly, right? Oh, I have, that variable's already defined, so I don't need to redefine it there. You know, it's not working. I'm not going to mess with it. Easier still would probably be to just make a function that returned it, right? We should write a function that makes this thing and returns the pointer to it. So instead of making it void, it should take a data object, pointer, right? And then it could do the same thing, right? Create the object and then return it. So just return the address, return that object right there, right? Return his address. And then down in main, it'd be real easy to call it. Right? PD is equal to make 2, like that, right? And then we can do that. Now we're setting up leaks, by the way, because we're not deleting our objects before we reassign them. So we would need to delete PD there because we're reassigning it here. And so whatever purposes we were going to use it for, do something with the data, do something useful there, we would need to delete it as well afterwards. All right, so that's about enough about pointers, right? I know that passing in a pointer to a pointer is a little bit oblique, but if you ever need to change the value of a pointer that you pass in and not just change the data that it points to, then you got to pass it in as a pointer by pointer, or you have to find another solution. And I would try to find another solution, like allocating it before I call the function, or passing it in as a reference somehow, or returning a new pointer, something like that. Looks like I've got build errors all over the place. Let's rebuild and see if it fixes. Yep, it fixed them. Okay. Let's go back to where we were. We're still talking about functions. We pretty much know everything we need to know about functions pretty much. We've talked about default values for functions. It's almost time to start talking about arrays. So using reference variables, we've talked about reference variables. Overloading functions, we've talked about overloading functions. The exit function, we've talked about exit functions. Stubs and drivers, we even talked about those, although that was part of the lecture that I got to re-record tonight. So we have pretty much covered all of this, I do believe. No, and that's not true because lecture M2 has not been shown to you yet, or the second part of the lecture. So we're going to recover these instead of me giving it as a separate lecture. I know that I've done function overloading though. Tell you what, I need to go and check something. I'm going to pause the recording. Victor, don't let me start lecturing without unpausing it, please. All right, so looking at the last lecture, just going to go ahead and insert the contents of it here. The first thing that it did cover that I've covered more thoroughly in this one is the idea of using references, right? And so if this function needs to change the value of x, we could pass it in as a pointer, but otherwise we just pass it in, you know, as a reference so that we could change it. Now, if we're passing it in purely for speed purposes, because passing things in by reference is faster than passing it in by value, especially if it's a data structure, right? Because a data structure will contain more than one piece of data. If you're passing it in purely for speed purposes, you're going to want to define it as a const to indicate that you're not changing it, right? But if you're changing it, you certainly don't want to make it a const. So in our other code, if I swapped over to it, excuse me, recent projects, guess we're on lecture N, not O. All righty. So here, if I was going to write something that took a data structure, a data object, a reference to it in order to do something like to print, to add the numbers up or something like that. So it's going to take the data object and it's going to add, you know, d.x plus d.y. But then we decide to change it to be a reference for speed purposes, because when we pass d in by copy, then it was copying 2 pieces of data. That's slower than just passing in 1, which is what you do. But since this is not modifying the data, we're just going to change it to const, right? And so down here, if we make a new data object of some kind, then we could pass it in by reference, right? So data d, d.x equals 1, d.y equals 2, you know, and then see out the sum of the data elements, right? Like that. What if we wanted to pass in PD here, right? We're not passing it in as a pointer, we're passing it in as an object. So we'd have to see out the sum star PD. Pretty much anytime you're going to access PD, anytime you're going to access a pointer, but you're trying to access it as an object, you can put a star in front of it to turn it back into its object, right? Just like if I tell you to go to mailbox 7, you know it's a mailbox because it's got a P in its name. So the act of going to that mailbox and looking at it means the star. I don't know if that makes sense or not, right? But here's how you reference an object via its pointer, right? By pointer. All right. So using reference variables as parameters, we have talked about that. Talked about it in a prior lecture, and we've talked about it today. So passing by reference, you can do that with the ampersand. Each reference parameter must contain an ampersand. The spaces are unimportant. How you want to define them is up to you. So this function here, you know, I could take out the spaces if I wanted to, or leave one of them in and one of them out. Works just fine. I think that's easiest to read though. An argument passed to the reference has to be a variable, right? Because it's supposed to be a reference to a variable. So you can't pass in a literal, right? So if F1, which takes a reference, I believe, no, it was F2, right? Changed by reference, F2 changed by reference. If I tried to call F2, where was that? Down here, right? If I try to call F2 and I don't pass in an integer, instead I pass in a literal, that's an error, right? Because it can't change it. Or what if I declared a variable, but it was a const, right? Well, I can't pass it in because it's a reference. It wants access to change it. If I wanted it to be able to be passed in, I'd have to go and make that variable a const up in the function. However, then it wouldn't be able to change it, which was the entire idea of that function. So it has to be of a compatible variable type. It can't be a literal and it can't be a constant unless it is declared as a constant reference. Wrong slide. All right. So overloading functions is when you provide functions with multiple versions of a function with the same name, right? So I'm going to write a function that accepts 1 string and a function that accepts 2 strings, right? We're going to write one called hello, which takes a string of a name and it just says hello to them, right? See out hi, comma, followed by their name. But that only works if their name is one name long, right? But what if we need to pass in a first name and a last name? We can provide two versions of it, right? String first name, comma, string last name. And it could see out hi, comma. That's great. Glad to hear it. I hope you actually uploaded. I'll check that later. Go away. All right, please go away. I said. All right, okay, so we're gonna say hello to first name and last name, right? So arrow, arrow, first name, arrow, arrow, followed by space, followed by arrow, arrow, last name, arrow, arrow, ANDL. Right? So now we can call it either way, right? I can go down into main and call hello, Bob, right? Or I could call hello, that seems to be underlined and I don't know why yet, you know, Bob, followed by his last name, Adams. Hello is undefined. Well, what did I call it? Oh, hello with uppercase H's. Why am I doing uppercases all of a sudden? There, that'll fix that, right? So it's overloaded. Hello is overloaded to accept either one string or two strings. Hope that makes sense. So that's what overloading a function is. They have the same name, but different parameter lists. The exit function. You use the exit function just to kill the program. It reaches an error state, and it's going to quit the program. And it doesn't matter whether it's in a function or in the main or whatever. See, if you stick a return statement inside a function, it just leaves that function, right? Program still keeps running unless that return was in main, in which case it means main is done. But you could write a function that does something, I'm not sure what, right? Void, you know, get input. And so we ask a question, you know, what is X? And then we declare a variable. And then, why did I set it equal to 0, right? And then we let them type it into X. And then for some reason, if X is less than 0, then it's a problem. We're going to print an error message and just kill our program. Now, is that a friendly way to do it? No, but you can do it that way. Program reaches a state from which it cannot recover. Just see out. Sorry, can't be negative. And then exit the program. I'm going to do that. Exit failure, right? Program's done. And it failed. And if a program launched our program, right, we wrote a script or another program that launched this program, it could check to see whether it failed or succeeded. Yeah, I am recording. Thank you very much. I would have been very perturbed if I did the same thing again this time. Okay, so I'm going to call get input, and I'm going to type in the thing that causes it to crash, and then I'm not going to call get input anymore. I'm going to remove it. Whoop. Because I don't want to have to type something every time I run it tonight. Right, so if I type in 5 for X, great, it works. And instead we have another error. I guess I hadn't run it since I was demonstrating passing in a reference. All right, so here I have a little bit of a mystery. It crashed, and I don't have enough information about where it was when it crashed. So I'm going to look at the call stack. The call stack shows me what line it crashed, and then what line called that line. And so it crashed when I passed in PD by pointer. And again, this is a reason for not using pointers, right? Because I had deleted the object, right? I had deleted the object, and so PD just contained, I mean, it pointed to something that was gone, right? I had a mailbox, but there was no house behind it. And so that's why that crashed. So let's make a new one, right? PD is equal to new data. And then let's set some values there. PD arrow greater than X equals 3. PD arrow greater than Y is equal to 4. Right. Then we can do that. Okay. Now it won't crash. And we can test out that function that's calling exit. Right. What is X? Let's run it with good input the first time. Now let's run it again. Bad input. Anything negative should call it. Yeah, it says sorry, can't be negative, and it just quit the program, right? You said exited with code 1. So exit underscore failure is a code 1, right? And if we exited with a success message, that'd be code 0. And again, like I said, if we called this program from another program, we launched it from a script, something like that, we could check that exit code. All right, so I don't want to do that. So I'm going to get rid of this. Let's add that as a comment way up here at the top. Exit causes the program to terminate. It can be in any function, right? All right, so the next topic, stubs. Wait, no. Yeah, so you can call exit success or exit failure, or you can make up your own numbers, but those two are generically accepted, where success is a 0 and a 1 is a failure. So stubs and drivers. What is a stub? It's a dummy function that's used in place of an actual function, right? So I'm writing some code and it's supposed to save to file. I haven't written that function yet, so I create a dummy function called save to file, and all it does is print a message that it was called, right? And it may also display parameters. Now, the opposite is when you write a function that tests another function by calling it, right? So we may need to test this make data function, and so we're going to write another function that calls it, calls it several times with different input just to check them. Now, this one, I can't really see any good way of testing it other than just doing, but we could do that. We're going to write a function, and it's going to be called bool, and it's going to be called test make data, right? And so it accepts nothing, right? But it's going to create a pointer to a data object, data star PBD, right? Equals null, so that we can pass it in. And then let's go ahead and call make underscore data and pass in that pointer. Oh, I didn't need to declare it as a double. I just declared it as a single pointer, right? Not a pointer to a pointer. But then I do need to pass it in its address like that. And if that works, right, we could check to see the value of X and Y if we wanted to, because that would validate that it worked. If PD X is equal to 1, ampersand, ampersand, PD arrow greater than Y equals 2, then C out, make data success, right? Else C out, make data failure. Like that. And if it succeeds, we could return a true. Else, we're going to return a false, right? So that's just a driver for our make data function. And the opposite of a test function is a function that just prints a message showing that it was called, right? That's called a stub. A stub is a function that merely prints a message. You will fill it in with actual code to do what you want. Right, so like bool file underscore open, and it's supposed to take some kind of string, right? But instead, we're just going to print a message, right? File underscore open, followed by the parameter that was passed in, right? Like that. And we're going to just put a comment, you know, unfinished function, like that. And that's all it's going to do. And it's going to return false to indicate that, you know, it's not working yet. So that's a stub, right? We're going to come back in and fill that in later. Are we really going to fill it in later? Nah, but that's the idea. So one way of programming is to go ahead and write all the stubs that you plan to fill in later and then go back in and fill them one by one. And if you've thought your program out enough in advance to do that, then you're doing well. All right, and so that is that. That is chapter 6 in a nutshell. The next thing we're going to talk about is arrays. So let's take a pause until 8:10. Then I can go and get my charger cable and stuff like that, and we will reconvene. Alrighty, so talking about arrays. What is an array? It's like the lists that you learned about in Python if you took fundamentals or scripting. It's just a sequence of values. Let me stop that, call that one lecture M2 and begin in now. Let's do that.